In the previous video, I said that firewalls are essentially routers, so it's important that we have a deep understanding of IP addresses to be able to configure interfaces and networks correctly in the future. And that's why I want to introduce you to the IPv4 subnet cheat sheet. This sheet shows us all the different network sizes that we can use to configure an IPv4 network, and it's going to be your best friend when you are designing a network from scratch. Starting from the smallest form of a network, just a single computer or a single device can be represented by a subnet mask or a network size of 255.255.255.255. This subnet mask can be converted to a shorter format, also known as the CIDR format or the CIDR notation, and it's a /32 for a single computer. How did this number come? We had to convert the subnet mask to binary and count how many ones are represented in the number, as IPv4 addresses are 32-bit addresses, and by converting this number to all ones, it's going to give us 32 ones. And that's why a single computer can be represented by a /32 format. Every subsequent network from this point is double the size of the previous network. So a /31 is double the size of a /32 with 2 IP addresses available, and a /30 has 4 IP addresses, and we keep doubling in size all the way until we reach the whole IPv4 space of 4+ billion IP addresses, or a /0. So a /0 represents the whole IPv4 space, and when IPv4 was first designed, they probably thought 4 billion IPs is a big number, it will never be used. However, with the introduction of the internet, the IP addresses were exhausted very quickly, and we had to rely on services like network address translation to be able to extend the lifetime of IPv4 until today. There is a newer version called IPv6, which we will discuss in a separate video in this course. However, IPv4 is more commonly used, and that's why I'm going to discuss IPv4 subnetting dedicatedly in this video. There are 5 landmark network sizes in this table that I want to discuss with you, starting from the /8 network. This is a very big network that contains over 16 million IP addresses. Example /8 network 10.0.0.0/8, which contains all IP addresses from the range 10.0.0.0 all the way to 10.255.255.255. Another network is 11.0.0.0/8, which contains all IP addresses from 11.0.0.0 all the way to 11.255.255.255. So a /8 network is easy to calculate because the first number stays static, and the next 3 numbers are the ones who change. The next network size is a /16. This is also a big network with over 65,000 IPs. Example for a /16 network 192.168.0.0/16, which contain all IP addresses from 192.168.0.0 all the way to 192.168.255.255. So a /16 network is also easy to calculate because the first 2 numbers are static and the other 2 numbers are changing. The third network is /24. This is a very familiar network that you've probably seen in your home network and contains 256 IPs. Example /24 10.250.252.0/24, which contains all the IP addresses from 10.250.252.0 all the way to 10.250.252.255. So in a /24 network, the first 3 numbers are static and the last number is the one that change. And finally, a /32 represents just a single computer, like 192.168.1.100/32. Now IP addresses fall into 2 categories: private IPs and public IPs. Private IPs represent the IPs that we are allowed to use in our home networks or our work environment. They are unique and dedicated to each local network, and they are not allowed to traverse the internet. There are 3 designated networks assigned for private use that you can choose from to design your own internal network. Those ranges are 10.0.0.0/8, which contains IP addresses from 10.0.0.0 all the way to 10.255.255.255. The second network is 172.16.0.0/12, which contains IPs from 172.16.0.0 all the way to 172.31.255.255. And the third network, or the familiar network based on home users, is 192.168.0.0/16, which is all IPs from 192.168.0.0 all the way to 192.168.255.255. Now, beside the three designated private address ranges, all other IPs are considered public IPs with some exception. And public IPs are assigned to people or companies by name, and they are not allowed to be used in multiple locations. And also, they are allowed to traverse on the internet. The exceptions for other IPs include the local host network, which is unique to every computer. So it's not just not allowed on the internet, but it also does not leave your computer. So it's unique to every device. Another exception is 169.254.0.0/16, which means your computer could not get an IP address automatically or indicate a DHCP issue. Now, example public IPs that we can see is the 12.0.0.0/8. This is a big network owned by AT&T. 17.0.0.0/8 is owned by Apple. 50.19.0.0/16 is one of many Amazon public networks. In fact, Amazon owns over 100 million public IP addresses, which is crazy considering this IP address space is exhausted and it's hard to buy these IPs. And Google has one of their network 72.14.192.0/18. So now let's take an example network 192.168.250.0/24. Because this is a /24 network, there is 256 IP addresses. We subtract the two unusable IP addresses, which is the first IP address of the network and the last IP address of the network, we get 254 host IP or usable IPs. Now, the first represent the network ID, which is like the title of the network, so it cannot be used to be assigned to a computer, for example, or a router. And the last IP is usually the broadcast IP, which is used to talk to every other computer on this network. So that leaves us with the usable IPs of 192.168.250.1 all the way to 192.168.250.254. So example computer on this network would have an IP address of 192.168.250.100. It can also be represented by a /32 CIDR notation because it's a single host or a single computer, and can also be represented in the subnet form 192.168.250.100/24. Now, if this computer wants to talk to other computers, there are two scenarios. He either wants to talk to someone in his own network, like inside his 192.168.250.0/24 network. In this case, he would send an ARB message to get the MAC address of that device, and it's going to be talking locally, so he doesn't need to talk to the router in this case. However, if he wants to talk to outside, for example, a different layer 3 network or the internet, he needs to talk to the gateway. The gateway represents the router, as routers can help computers get out of the network to other networks. So usually first usable IP is the router IP 192.168.250.1. Then the router will direct the traffic to the other network based on the route table. So now, for a client to be able to network correctly, it needs a few pieces of information. The first one, it needs its dedicated IP address and the network size or the subnet mask. And finally, the gateway IP, which is the router IP, to talk to other networks. If I were to not provide the gateway IP to my client, he can talk to everybody in his own network only, but he cannot talk to other networks. Number 4 is the DNS server, which is very important to be able to resolve names like domain names like google.com or elasticsource.com. DNS server is required to change from name to IP address so the computer can understand how to route this traffic. You can ask users to manually input this information in their computer, like the IP address, the subnet mask, the gateway, and the DNS server. However, it's a lot of work, especially for a large scale of computers. And that's why there is a feature called DHCP for automatically assigning IP addresses to computers. DHCP service is awesome because it contains 4 short messages that finish the whole IP assignment process for us automatically with absolutely zero work on our side. The first step in a DHCP process consists of the client or the computer that want to join the network sending a discovery message from his computer with no IP address where actually they are sending with 4 zeros, which is not a valid IP address, to the IP address 255.255.255.255, which is a broadcast IP address specially used for DHCP. And they send this on port 67. So 67 is the port used for DHCP service, and they contain a few information inside, but the most important part is the computer name and the MAC address. The router then responds to the machine using its MAC address by addressing it with a proposed IP address that it can use to join the network, and it responds on port 68. So the response comes on a different port, and it would contain something like, I can give you 192.168.250.100 plus all the other information we talked about before, like the subnet mask /24, the gateway 192.168.250.1, and other information like the lease time or the time they are allowed to maintain this IP address before they have to ask for a new IP address or ask for renewal. And it asks the client to send them an official request for this IP address if they want to proceed. So in this case, the client or the computer would send another message using the same IP address 255.255.255.255, port 67 again, and it would say, can I officially get the 192.168.250.100 with the other information like the gateway and DNS server. And then the router would say, okay, you got it, I saved your information, now you have this IP, you're allowed to use it. So by sending these short form messages that happen over a few seconds, you get to configure all the network devices, and on a large scale, it's such a time saver. So DHCP is absolutely one of the best services you can use on your router. That's why most consumer routers already have DHCP enabled. As you progress in this course, we're going to start configuring Fotigate interfaces as the gateway for our networks, and start configuring firewall policy and route traffic in between to our needs. And I'll see you in the next video. Thank you for watching.